Welcome to my channel Chemistry Revision KCSE 2023, and today we are looking for one work, the flame. You can get me on WhatsApp 0741 892 55. So let us look at the flame analysis. All the questions that can be set from the flame. The diagram below shows a Bunsen flame when in use. Studied and answer the question that follows. So we have F, then we have M, then we have K. The question is name the part labeled F, M, and K. So naming this part, as you can see that F is the type of the flame is a non-luminous flame. A non-luminous flame, mostly cases, it has three regions. We have the outermost region is called the pale blue region. Then we have M, which is the innermost part of the flame. This one is almost a colorless region. And then we have K, which is the chimney. Describe an experiment that could confirm that a region labeled M is unsuitable for heating. When describing an experiment, you need the materials to be used or the apparatus, for example. You can need a manila paper or a wooden splint or a matchstick. After having the material that you can use, then you give the procedure to be followed, and then finally you give the observation, but do not give the reasons for your observation. Now in this case here, what are some of the materials you need to use? You need a manila paper, you can also need a wooden splint, or you can need a matchstick. So what do? You give a procedure to be followed, using a manila paper until you show that this region here is unsuitable for heating. So slide a manila paper into the region. So you slide a manila paper or wooden splint into the region, and remove it quickly before it catches fire. So you slide a manila paper or a wooden splint into the region, and then you remove it quickly before it catches fire. So if you slide a manila paper or a wooden splint and then you remove it quickly before it catches fire, the inner part remain unburnt. So that is the observation. So the inner part remain unburnt. So in this case, you have the materials or the materials, that is a manila paper or a wooden splint. Then we have the procedure to be followed, whereby you are supposed to slide in a manila paper or a wooden splint in the region, and then you remove it quickly before it catches fire. The inner part remain unburnt. In a diagram, this is the result you can have. So if you can have that, this is our wooden splint. You can have if you use a wooden splint, this is the result that you can get. You can get this result when sliding in that because the outermost part of the flame, that is the pale blue region, this region here, it is the hottest. So this part, it will pan this side. So you can have this one as the pan part. And this one here, so we have this is an pant and pant part, meaning that this region here contains is unsuitable for heating, because the outer region here, which is the pellet blue region, is the hottest part of the flame, so it can pan the wooden splint. Then the inner part, which is of course region M, remain unpanned, because this one contains unpanned carbon particles. We proceed. Describe an experiment. Describe an experiment to show that the innermost region of a Bunsen flame contains unpanned gases. We have this flame. We want to show that the innermost part of the flame contains unpanned gases. Which region here in this case? So if we have that it is our flame, we are talking about this region. So in this case, as I said earlier, that when describing an experiment, you need the materials to use. So in this case, to show that this region here, which is of course, which was region M, that this one contains unpanned gases, you need an apparatus, or you need something that will pick the gas particles from this region. And when you light at the you ignite, or you light at the opposite end, it will burn with a small flame, indicating that the region contains unpanned carbon gases. So in that case, you will be using the you can use the glass rod tube. If you can have a glass rod tube, and then you insert into the region, if you can have the glass rod tube, and then you insert into the region, it will pick some gases. It will pick some gases from the inner the region. So you can have a glass rod tube, which you can insert into the region. It will pick the gases. And if you light at the opposite end, at this region here, it will burn with a very small flame, indicating that the region contains unburned carbon gases. So insert a glass rod tube in that procedure. Insert a glass rod. Insert a glass rod tube into the region. It will pick some gases. It picks some gases. And if we ignite from the opposite end, it burns with a small flame. Indicating that the region contains unburned gases. Indicating that the region contains unburned gases. So if you insert a glass rod tube, it will pick some gases from this region here. So if it will pick the gases, the gas particles will be moving, and if you ignite at this opposite end, you will be getting a small flame. So you will be having that one as a small flame, indicating that the region contains unburned gases. So if this is the the type of a flame you have, which is an luminous flame, and therefore you insert a gross slot tube into the region. So if you insert a gross slot tube into the region, it will pick some gases from the region. So if you insert the gases into that region there, so it will pick some gases from the region. And if you ignite at the opposite end, this region here, it will burn with a very small flame, as you can see, indicating that the region contains unburned gases. We proceed. Explain how the luminosity of explain how the luminosity or a brightness of a Bunsen flame can be increased. So how can you increase the luminosity or the brightness of a Bunsen flame? This is simply by closing the air hole. So by closing the air hole, so the luminosity of the flame can be increased by closing the air hole. So this one here by closing the air hole. So that is how you can increase the brightness or the luminosity of the flame. Name the flame represented in the figure. So the flame that is represented on this figure, remember we said we have two types of the flame. So the flame represented on this figure is a non-luminous flame. So this is a non-luminous flame. Another question, name another type of the flame produced by a Bunsen burner. So we have two types of the flame, non-luminous flame, then we have luminous flame. So if on the diagram we have a non-luminous flame, so the other type of the flame is luminous flame. Is the luminous flame. So another question we look at, explain why a non-luminous flame should be converted into luminous flame when not in use. Explain why a non-luminous flame should be converted into a non-luminous luminous flame when not in use. Why do we convert the luminous flame in the non-luminous flame into luminous flame when not in use? Why do we convert? So this is a non-luminous type of the flame. This one here is a non-luminous type of the flame, as you can see, being produced by the Bunsen burner. So we can close the air hole. When closing the air hole, we convert the non-luminous flame into luminous flame. So what you can see, the non-luminous flame is invisible. It cannot be easily seen. But if you convert it to a non-luminous flame, if you convert it to luminous flame is visible. So non-luminous flame is less visible. Luminous flame is visible. So we can convert the non-luminous flame into luminous flame to avoid some accidents, to avoid the accident. So non-luminous flame is less visible due to its blue color, as you can see. So non-luminous is less visible due to its blue color. Due to its blue color, while non-luminous flame is visible, so we can have while luminous flame is visible. Why is it visible? Because it is large and brightly colored. It is large and brightly colored, which makes it visible, which makes it more visible, which makes it visible, hence reduce fire accidents. Hence reduce fire accidents. So this is the reason why you can convert why a non-luminous flame should be converted into luminous flame when not in use. So non-luminous flame is less visible due to it is blue color, while luminous flame is visible. It is large and brightly colored. That is the luminous flame, which makes it visible. Hence, it can reduce fire accidents. Give 4 differences between luminous and non-luminous flame. We can use a table here. We start with a non-luminous. Then we have luminous. So you can use that table. Non-luminous is very hot. So this one here, very hot. On the other side, this one is fairly hot. Fairly hot. Luminous flame, non-luminous flame is not sooty. So this one is not sooty. Whereas on the other side, this one is sooty. This one is sooty. Non-luminous flame is blue in color. So you can have this one is blue. This one is yellow. So you can see this one. So these are an unluminous flame. It is blue. If we close the air hole, we can have the luminous flame, which is yellow. So this one is blue, this one here is yellow. Another difference, this one is very hot, not sooty. This one is sooty, blue, then this one is yellow. So a luminous flame, an unluminous flame, an unluminous flame has 3 regions. Of course, the number of regions cannot be used to give the differences. So this one has 4 regions, this one has 3 regions, but we cannot write this one here because number of regions, the size, the sound cannot be used to give the differences. So this one is very hot, not sooty, blue, yellow. Non-luminous flame, no striking back. So we have no striking back. No striking back. Okay, on the other side we have, there is a striking back. Striking back. So the number of regions, so we can an NP here, number of regions, size, then we have sound. Sound, you can set at pans quietly, pans with a rom sound. So number of sound. You can also have when air hole. So we have air hole. So when air hole is closed or opened, cannot be used to give the differences. This one cannot be used to give the differences. Correct. So number of regions. So you cannot say that the one it has 3 regions and the other one has 4 regions. So number of regions, size, large and unsteady, small and unsteady like that one cannot be used to give them differences. Sound, pans quietly, pans moderately, so we can say they cannot be used to give the difference. So the number of regions, size, sound and air hole cannot be used to give the differences. Give the function of the following parts of a Bunsen flame. Number 1, we have an air hole. The function of the air hole, it allows air to enter the chimney. So this one allows air to enter the chimney. Then we have a collar. The function of a collar regulates the amount of air entering the chimney. This one is regulates the amount of air entering the chimney. Then we have the chimney. The purpose of the chimney is allow mixing of air and respiratory gas to produce a flame when pan at the top. So this one allows mixing of air and respiratory, allows mixing of air and respiratory gas. So it allows the mixing of air and respiratory gas, which can be burned at the top to produce the flame. Then we have a pace. The purpose of the pace, it supports the burner. So pace supports the burner. It is adapted to this one because it has a large surface area which can offer a support. So we have another question here. Explain the procedure for lighting or igniting a Bunsen burner. How can you explain this one? So this one, you need a procedure for lighting or igniting a Bunsen burner. First of all, how do you light the Bunsen burner? You have the collar, then the collar must be adjusted. You connect the burner to the gas tap using rubber tubing, and then you turn on the gas tap, and immediately once you turn the gas tap, you ignite the top of the chimney using a lighted match. So that is the simple procedure for lighting the Bunsen burner. So first of all, adjust the collar to ensure the air holes are closed. Adjust the collar to Number 2, connect the burner to the gas tap. To the gas tap using a rubber tubing. Then this rubber ensure that the rubber tubing, it has no side leaks. So when you ensure that it has no side leaks, then you connect the burner to the gas tank using this rubber tube, because if it is leaks, the gas will get out and then it might cause an accident. Then turn on the gas tank and immediately ignite the top. Immediately ignite the top of the chimney. The top of the chimney using a matchstick. So that is a simple procedure for lighting a Bunsen burner. You adjust the collar to ensure the air holes are closed. Then connect the burner to the gas tank using a rubber tubing. Ensure that this rubber tubing has no leaks sides. Turn on the gas taps, and immediately once you turn on the gas taps, ignite the top of the chimney using a matchstick. Now, one of the differences between luminous and non-luminous is where we have a striking back. The luminous flame, there is no striking back, whereas in a luminous flame, there is a striking back. Now, what is that striking back? What is striking back or sucking back or panning bag. What is it? So what is it as used in the Bunsen burner flame? So when you are talking about a panning or a striking bag or a sucking bag, is the name given to a phenomena where the flame goes down. So this one is the name given to a phenomenon where the flame down the chimney and goes off. And this happens when the gas being pumped faster than can be supplied. So the name given to a phenomenon where the flame goes down the chimney and it goes off. That is when we talk about the panning bag, striking bag, or sucking bag. It happens when the gas being pumped faster than can be supplied. So in that situation, you can have a striking bag, a panning bag, or sucking bag. We have another term which is a hybrid, which is used in a luminous and non-luminous flame. So when is the hybrid? This word here, when is the hybrid of a non-luminous and a luminous flame is produced? So a hybrid of a luminous and non-luminous flame is produced if the air holes are partially opened or closed. So if the air holes are partially opened or closed, so you can be having the hybrid type of the flame. State 2 advantages of a non-luminous flame. What are the advantages of this non-luminous flame? You know, non-luminous flame, it is a type of the flame which is used for heating. Why is it used for heating? Because it is very efficient in it is very hot. It is very hot, and therefore it does not form soot. That is why it can be used for heating. So what are the advantages of an non-luminous flame? One advantage, it gives out a lot of heat. So this one, it gives out a lot of heat, hence very efficient in heating. That is one. Two, it does not form soot. It does not form soot, hence it leaves the apparatus clean after experiment. After experiment. So those are the two advantages of non-luminous flame. It gives out a lot of heat which can be used for heating, very efficient in heating. It does not form soot, hence leaves the apparatus clean after experiment. Now, what are the disadvantages of this luminous flame? So, one of the disadvantages of this non-luminous flame, it uses a lot of reparatory gas in panning. It uses a lot of two, cannot be used for lighting purposes since it produces very little light. Now, another question we look at uh, state two reasons why the non-luminous flame is preferably used for heating. Why do we prefer this non-luminous flame for heating? One reason why it is preferred for heating, it produces a lot of heat. Two, it does not produce soot. Those are the two main reasons why they are preferred for heating purposes. What is the first aid? What is the first aid in case of a pan by an acid in the reparatory? So the first aid that wash the pan part with a lot of cold water. Now, why is a luminous flame pan with a yellow flame? Why does it pan with a yellow flame? So it consists of a hot carbon particles which give out a bright yellow light, and that is why the luminous flame produces a yellow flame. So we can write this one as So it consists of a partially burnt thin particles of white hot carbon which gives out a yellow light. How can the hotness of a Bunsen burner be increased? So the other question, how can you increase the luminosity or the brightness of a Bunsen burner? You increase by opening the air hole, by closing the air hole. So if you want to increase the hotness of a Bunsen burner, is by opening the air hole. Now, give two reasons why a luminous flame is not used for heating. So why a luminous flame is not used for heating? It is less hot and it produces soot. Now, another question is state the uses of a flame. What is the flame used for? A flame is used for luminous is usually used for lighting because it produces much light. And then we have an non-luminous is used for heating because it is very hot and that does not produce soot. So we have luminous is used for non-luminous is used for heating because it is very hot. And does not produce soot. Another question is state the condition under which a Bunsen burner produces a luminous flame. A luminous flame is produced when the air hole is fully open. Now, write an equation for the reaction that takes place in a luminous flame, assuming the laboratory gas is butane. Assuming the laboratory gas is butane, butane is CH4, C10H4. So we have, no, it is C10CH butane. C4H10. This is butane. So assuming the reparatory gas is butane, write an equation for the reaction that takes place. Write an equation for the reaction that takes place, assuming that the reparatory gas is butane. So we can have and we are panning this one. So assuming the reparatory gas is butane, this is the type. One of the region in the non-luminous flame is the unburned gas. Describe how the presence of this region can be shown using a wooden splint. So the question is we need a Manila paper we need a Manila paper or a wooden splint, but in this case here the question is very specific, straightforward, that you need to use a wooden splint. So what do you do? Slide a wooden splint across the middle part of the flame. The central part of the flame remains unburnt. So the middle part remains unburnt. And then the outer part burns. So you can also use a diagram of that wooden splint. It's also acceptable. And if you can use this well-labeled diagram, you can have that this your matchstick. So you slide in, then we have the middle part remain unburnt. Middle part remain unburnt. Then we have the outer part pans. So we have this one here as the burnt region. The burnt part like that. So you can either use the diagram, or you can explain. It's like a wooden splint across the middle part of the flame, the middle part of the flame, the middle part of the wooden splint remains unburnt. The outer part burns. So that one can be shown on the diagram. You visit my YouTube channel. Kindly subscribe, click the notification bell such that you will be notified once I upload a new video. In our next video, we are going to see the analysis of air and combustion. Thank you. God bless you.